Hey everyone, so we're going to continue from where we left last time. So let's try and evaluate this limit over here. So as usual, we're going to try and plug in first. So let's just plug in x equals 0 everywhere. So this is going to give us 0 over 0, and this is an indeterminate form. So we might think of factoring, but can we really factor in this case? Will that help us? I don't see a particularly simple way to factor this, right? So that's where the idea of conjugates comes into place. So first things first is what exactly is a conjugate? So I think it's best to explain it by an example. So the conjugate of this expression over here, a plus b, it's simply the same two terms, a and b, but just that the sign between them is going to be flipped. So the conjugate of a plus b is a minus b. The conjugate of x squared minus y is x squared plus y. Conjugate of x squared plus y is x squared minus y. The conjugate of the numerator of our limit over here at the top, under root x squared plus y minus 3, is the same two terms, right? The x squared plus y under root 3, but just that the sign between them is going to be flipped. So, I mean, it's a rather simple idea. So that's what a conjugate is in simple terms, right? So when exactly do you use the conjugate to evaluate the limit? So you're generally going to use it when either your numerator or the denominator, right, is going to have some sort of a square root plus minus something else, right? So the something else could be a number, it could be another square root as well, it could be anything. So like for our example over here, right, you can see that we have a square root and it's plus or minus some other number, which is 3. So in this case, that's an indication that we need to use the conjugate method, right? And in order to use it, you multiply both the numerator and the denominator by the conjugate. Moving back to our example, we're going to multiply both the numerator and the denominator by the conjugate of the expression that contains the square root. So in this case, the numerator is what contains the square root. So we're going to multiply both the numerator and the denominator by the conjugate of x squared plus 9. And now instead of writing minus 3, I'm just going to flip the sign and write plus 3. And I'm going to divide by itself. So, mathematically, we aren't doing much, right? Because this two can just simply cancel out. So again, we're just playing around with, the function. Okay, so what do we do next? It might look a little tricky at this point, but it actually isn't. So how we're going to go ahead is that we're going to use the difference of two squares. So we say that when we have a squared minus b squared, this can be written as a minus b and a plus b, right? So this goes either way, right? So if you have a minus b, a plus b, you can write this as a squared minus b squared, right? So look up close over here. This is your a, this is your b, this is your a, this is your b, right? And there is a minus and there is a plus. So what exactly is this? It's just the difference of two squares, right? So you can basically just write it down as the limit as x approaches 0. Your a is x squared plus 9 under root, right? And your b is a 3, right? So using the expression over here, we are going to put the minus sign over here, and we're going to square both our a and our b, right? At this point, you're just going to leave the denominator as it is, right? So I'm just gonna put it as x squared multiplied by the root plus 3. Okay, so then let's go ahead and further evaluate this. So this is the limit as x equals 0. Squaring the square root basically gets rid of the square root, right? Because the square root of x multiplied by the square root of x is simply just x, right? So this gets rid of the square root over here. So this becomes x squared plus 9 minus 9 over x squared multiplied by x squared plus 9 under root plus 3. So at the top over here, the plus 9 and minus 9 will cancel out. So you're just going to have x squared divided by x squared multiplied by x squared plus 9 plus 3. So now we can cancel the x squared and x squared. That's why, you always want to leave, the other part of it as is in case, there is a chance of some cancellation that could happen, right? So this just simplifies the original function to 1 over under root x squared plus 9 plus 3. Now let's try plugging in over here. So it's just 1 over root 9 plus 3, which is just 1 over 6. And yeah, we just solved this limit. So therefore we can say that the limit as x approaches 0 is 1 over 6. So that's how the conjugate method works. It looks a little intimidating, but once you get a hang of it, it's not too difficult. But as I mentioned, the main step is basically this part, this bit over here, the difference of two squares. You need to be able to apply this pretty well, right? So you need to know, you need to be used to this. And I guess once you have that done, it's not much of a problem. All right, so let's look at this other example. As usual, we're going to try and plug in first. There's a very slim to none chance that it's not going to be um, an indeterminate form, but let's see if we're lucky today. Unfortunately, no. This is 0 over 0, and this is indeterminate. So as you can see that you have a square root, and then you have the square root is plus minus some other term. So that's all indication that we're going to have to use the conjugate method, right? So, you might be thinking that why aren't we multiplying both the numerator and denominator, right, by the conjugate of the numerator in this case, right? You have two different terms. But see, you could do that, but how does that help us, right? If I multiply this, right, that doesn't help us simplify, the function in any way. It would rather just complicate it. So you're best off, right? You're best off by multiplying both the numerator and denominator by the conjugate of the term that contains the square root. In this case, now, previous example, we multiplied by the conjugate of the numerator because it had the square root. But in this case, the denominator has the square root. So we're going to multiply by the conjugate of the denominator. So we're going to multiply under root x plus 4 plus 3. I flip the signs because it's the conjugate. And this side as well. So like I mentioned in the previous example, you're going to leave the top part as it is, right? In case, there is some cancellation later on. And by difference of two squares, your first term is root x plus 4. So I'm just going to write this over here. You're going to square it minus the second term is 3. You're going to square it. Recall the difference of two squares, right? That's the whole catch over here. When you square a square root, so that gets rid of the square root. So we've gotten rid of that. So this is simply the limit as x approaches 5 of x minus 5 multiplied by root x plus 4 plus 3 divided by x plus 4 minus 9. Right, so I can just try and simplify this a little bit. We can now cancel the x minus 5 and x minus 5. That's why, we didn't simplify this part in the first place, right? Because there could always be a chance of, getting an opportunity to cancel it. So we've now simplified our original function to root x plus 4 plus 3. And now let's try and plug in, see if we get a definitive answer. So you can add root 5 plus 4 plus 3. So this is root 9 plus 3, which is 3 plus 3, which is 6, right? So therefore your limit as x approaches 5 is simply 6. Let's look at another example. So first is you're going to try to plug in, but if you do it, you will realize that it comes down to 0 over 0, which is indeterminate. So you have your numerator, which contains a square root plus minus another term. In this question, the other term is a square root itself. So that's all the signs we need to use the conjugate method, right? So you know that next thing over here is to multiply both the numerator and the denominator by the conjugate. So the conjugate is the same two terms, but the sign has to be flipped, which we changed. Right? We're flipping the signs from minus to plus. Using your difference of two squares on the numerator, right? Your first term is going to be this root of 2x, and your second term is going to be root of x plus 2, right? So using the difference of two squares, that's your first term, you're going to square it, minus the second term, which is the root of x plus 2, and you're going to square it. Remember, guys, that whenever you have this sort of algebraic things going on, right, and you have more than one term, right? So like in the second one, it's x plus 2. Always try to put it in brackets, because when you get rid of the square root and when you open the brackets up, you're most likely going to get the correct sign. But if you don't put the brackets, it's going to be very error prone. Try to use brackets where possible. Divided by x squared minus 2x multiplied by root of 2x plus x plus 2. Right, so this just becomes the limit as x approaches 2 of 2x minus x plus 2. We got rid of the square roots over, yeah, the whole denominator. So now let's go ahead and simplify the numerator and see the essence of putting brackets, right? So 2x minus, now let's open up the brackets. So it's going to be minus x minus 2. You see, this part, minus 2, right? If you don't put the brackets, you're most likely going to end up using the same sign of 2, which was plus, but that would give you an incorrect final answer. So that's why you should always try and use the brackets, right? This just becomes x minus 2 over x squared minus 2x and root of 2x plus x plus 2, right? Now at this point, if you try and plug in and you think that, we're done, that's not the case, because if you try and plug in, you're still going to get 0 by 0. So what do you think needs to be done next? Remember, these techniques don't work in isolation, right? You have to use multiple techniques at times together to get the limit, right? So in this case, if you look closely, you can factor this. You can factor this further, right? So we can factor the x squared minus 2x to give us x minus 2, right? Now doing so gets rid of x minus 2. You have x minus 2 in the numerator over, we factor this, so I'm going to write x minus 2 multiplied by root of 2x plus root of x plus 2. So now we're getting rid of this and this. So now we've simplified the function to 1 over x multiplied by root of 2x plus root of x plus 2. And now let's try plugging in. So that's just going to be 1 over 2 multiplied by 2 times 2 is 4. So that's root 4 plus 2 plus 2 again is 4. So root 4. So this is just 1 over 2 multiplied by root 4 is 2. 2 plus 2 is 4. So 2 times 4. So that just becomes 1 over 8. So therefore we can say that the limit is just equal to 1 over 8. Okay, so let's look at this final example involving conjugates. So if you try and plug in, you're going to end up having 0 over 0, which is indeterminate. And since we have square roots, it makes it pretty obvious that we have to use the conjugate method. But in this particular example, both the numerator and the denominator have a square root. So we take the conjugate of what? The numerator or the denominator? So in situations like this, what you do is you take the conjugate of both. So how we're going to rewrite this is limit as x approaches to, write down the function as it is. So first you multiply by the conjugate of the numerator because it contains a square root over the same thing. So mathematically it's just 1. And then you multiply by the conjugate of the denominator because that also contains a square root. So I'm just flipping the signs between the two terms, right? So now I'm gonna use the difference of two squares between this, and a second time between this and this here. Alright, so for this green side we have root 6 minus x minus 2 multiplied by root 6 minus x plus 2. So the 6 minus x on root, right? Root 6 minus x becomes your a, and your b is just the 2, so it becomes a squared, which is root 6 minus x squared minus b squared, which is 2 squared. So this will just become the square root and the square will cancel. So 6 minus x minus 4, which is just 2 minus x. Okay, so the green side becomes 2 minus x, and the yellow side will become, now your a is going to be root of 3 minus x, and your b is going to be 1, so it becomes a squared minus b squared, so that is just 3 minus x minus 1, so it becomes 2 minus x, right? So I'm just going to rub this off. The green side becomes 2 minus x, and then you write down what's left over, so which is under root 3 minus x plus 1, and the yellow side also becomes 2 minus x, and what's left over is root 6 minus x plus 2. So 2 minus x and 2 minus x cancels out, and you're left with the limit as x approaches 2 of root of 3 minus x plus 1 divided by root of 6 minus x plus 2. Let's try plugging in. So this is going to be root of 1 plus 1 over root of 4 plus 2. So this is just 2 over 4, that is a half. Therefore, just like that, the limit becomes 1 over 2.